Hi, I'm JAYAPRAKASH. IC number is PIC16F882. And the assignment first question is draw the clear diagram of given microprocessor, a microcontroller or IP port selected. And second, the first part is internal diagram of each and every part. This is my given processor IC circuit block diagram. In block diagram, AI used was program counter, configuration, flag program memory, 8-level stack, RAM, instruction set, instruction decode, timing generation, internal oscillator block, power up, oscillator startup timer, power on reset, watchdog timer, brownout reset, add MUX, FSR REG, status REG, registers, FSR and status registers, MUX, ALU, W register, and the PQ RTA, PQ RTB, PQ RTC, PQ RTE, analog to digital converter, analog comparators and references. These are the given and used for the given block diagram of my circuit of my given IC. And the internal diagram of block is program memory stack. Internal memory map and stack that have stack level 1, 2 and up to 8, and they have reset vector and have interrupt vector. Page 0 is on chip program memory. And my second question is provide the instruction set of the microprocessing element, microprocessor or microcontroller. My microprocessor. These are the given instruction sets. At RA1, that is general purpose input or output, then is RA1. At AN1, that is AYD channel 1 input, and C1 to N1, it is comparator C1 or C2 negative input. Similarly, like RA6 has OS C2, OS C2 has master clear with internal pull up. We have CLK OUT. CLK is output, which is F4C per 4. Similarly, RB2 for AN8 P1B, these are given. For RB2, that is general purpose input or output, individually controlled interrupt on change, individually enabled pull up. At AN8, A and D channel 8, P1B, PWM output. And the third question is explain the microprocessing element architecture. The microprocessor architecture is instruction set architecture in PIC16F882 RIS architecture. RIS architecture is reduced set instruction set architecture. The man behind is make hardware simply by using an instruction set composed of a few basic sets for loading, evaluating and storing operations, just like a load demand will load data, store command will store the data. The same points, simple instructions are used in RIS structure. RIS helps and support few simple data types and synthesize complex data types. RIS permits any register to use in a context. One cycle execution time. RIS contains large number of registers in order to prevent various number of interactions with memory. In RIS, more RAM is required to store assembly level instructions. Reduced instructions need a less number of transistors in RIS. Because of this, my microprocessor select RIS architecture. Fourth question is correlate the microprocessing element architecture with architectures discussed in module 1 and 2. We have discussed the von Neumann architecture and Harvard architecture in module 1, and architecture in my microcontrollers RASC architecture. So even when we can correlate RASC architecture with the Harvard architecture, correlate points of RASC architecture and hardware architecture. Reduced instructions need a smaller number of transistors RASC. Compiler is used to perform the convolution operation means to convert a high-level language statement into a code of its form. As we use less number of transistors, both the architectures are very complex to design. Both RASC architecture and Harvard architecture use only single clock cycle. The amount of work that computer can perform is reducing this operating load and store instructions. Same way, Harvard architecture have different locations. Fifth question is elaborate register organizations of microprocessing element. Of my microprocessor RASC F882. In this CLR, SET and INV peripheral registers, HI and LO registers. These are some of the registers used in this. As the name of the register implies, the value of return to set CLR or INV register effectively performs the Peripheral register. The most common way is through peripheral registers. Hardware peripherals exports the functionality to software through a set of registers. Peripheral registers must be confused with CPU registers. Peripheral registers mapped at physical addresses, not virtual ones. So in the operating systems with memory protection are accessible only from with the OS kernel. In a microcontroller environment, instead they are freely accessible since there is no memory protection. My sixth question is explain the type of algorithm used for signed or unsigned calculations, addition, multiplication, etc. In my process, algorithm is Booth algorithm is multiplication. So these are the. My seventh question is find what type of control unit logic unit used and correlate its performance with the type of control unit in module 3 in CO syllabus. In module 3 there is control logic unit. The control logic unit is a component of a computer's central processing unit. It directs the operation of the processor, tells the computer's memory, arithmetic and logic. Unit and input and output devices, how to respond instructions that have been sent to the processor. Cell and the core independent peripherals improve system responses and determination. CIPs also allow the CPU to execute more complex tasks, such as human machine interface, that means HMI, control algorithms, human machine interface, that is HMI, control algorithms remain in low power mode to converge power until processing is required. Safety criticals of these are given below, like WWT, CRC, POD and POR. And my eighth question is explain the memory managed system. The processing element selected list is addressing capabilities, memory mapping technique followed, find advantage of memory design and management techniques over the concepts given in module 4. As per the module 4, PIC32 microcontrollers provides 4 GB virtual memory address space. All memory regions, including program memory, data types as receipts in the address space. As per the 32-bit native data with separate boot, flash memory for protected core, simple memory mapping with fixed mapping, translation, unit the PIC 62F88. So we coming to multiply, divide, unit. Microactive UC course includes a multiply, divide unit that contains a separate pipeline for multiply, divide operations like multiplication and divisions. This pipeline operates in parallel with integer pipeline and does not stall in the IU pipelines. This allows long running operations to the partially masked by system stalls and or other integer unit instructions. My ninth question, elaborate the pipeline parallel processing units of the unit and hazard management technique. Pipeline is the process of accumulating instructions from the processor through a pipeline. It allows storing and execution instructions in a orderly process. It is also known as pipeline processing. In this pipeline system, each segment consists of an input register followed by a combination circuit. The register is used to hold data and combinational circuit performs the operation on it. The output of combination circuit is applied to input registers of next segment. Types of pipeline in two categories: arithmetic pipeline and instructional pipeline. Arithmetic pipelines are usually found in most of the computers. They are used to floating point instructions, multiplication of fixed point numbers, etc. Example: input to floating point arithmetic pipeline is here is A and B are MAKKENA's sufficient digit of floating point numbers, while A and B are exponents. Floating point addition and subtraction are done in 4 parts. 4 parts are compare the exponents, align the matrices, add or subtract matrices, produce the result. Second is instruction pipeline. This stream can be executed by overflowing fetch, decode and execute phase of an instruction cycle. This pipeline will be more efficient if the instruction cycle is divided into segments of equal duration. Last question, the 10th question, find whether processor level parallelism is available in the element selected. Illustrate caching, coherence are practical for handling memory, HIT or MISs. In my IC, LDM instructions with PC in the register list and without plus increments. Parallel processing is a method of simultaneously breaking up running program tasks on the multiple microprocessors, thereby reducing processing time. Processor level parallelism may be accomplished by a computer with 2 or more processors. Cache coherence practical for handling hit or miss. Coming for cache coherence is intended to manage such conflicts by maintaining a coherent view of the data values in multiple caches. Multiple caches are send the address and read the operations at the next level. Eliminate memory operations, decrease the number of misses, decrease the miss penalty, decreases the cache or access times, hide memories, latencies, increase the cache throughput, output, increase memory value. These are the given questions for DA-1. Thank you.